live. So just a quick recap here. Yesterday we learned how to find the MCT, so mean median mode, but it's not just mean median mode that we are interested in, but those are the measures of central tendency, right? So your mean and your median can be found, right, by typing in the data into L1. And so if you just go one variable stats and you calculate that, you can get that information right from here. It also helps you to find the range because you will subtract the greatest and the lowest value. And to find the mode, you just got to go back to your sorted list, right, and figure out which number appears most often or which numbers appear most often. Be very expect everything to have units, right? Centimeters, inches, degrees Celsius, yards, you name it, minutes, seconds, whatever. There will be units attached to them. We go to work, like it'll be a work problem, right? It tells us also, this is something new. You've never heard of that before, standard deviation, right? It's like, what is that number? And the standard deviation is a measurement that helps, especially when you're comparing it to other data. It tells you whether data is closer together or further spread out, right? It's the average distance, listen carefully, it's the average distance from every point to the mean. That's what that number is. So the bigger this number, the further apart on average the points are from that center, which is the average, right? So, and there's a direct correlation between the standard deviation and the range. If the range goes bigger, so let's say you have a range of 40, you should also notice that your standard deviation would be going up, right? You should definitely notice that. And so on its own, standard deviation doesn't help us much. On its own, it's more important when you're comparing it to other data points, okay? To another set, perhaps. Like let's say I have 2 grade 11 applied classes, right? I enter my test scores. One of my applied classes gets a 4.9, let's say, and the other one gets a 7 point something as my standard deviation. What does that tell me? It tells me that that second class, it's a bit more spread out. You've got more spread in your data collection, in my test scores, right? If it's a smaller standard deviation, everybody's closer to the average. And as a teacher, you want that. You want things to be closer clustered because that means that everything is consistent. What you're teaching, everybody's understanding that concept, right? And so even if the average is low, you can work with that. You can bring it up, right? You can maybe teach it a different way, but it means that what's being understood is kind of consistent. Okay, all right. So we compared Toronto and Winnipeg yesterday. We entered, when you have 2 sets of data, enter them into L1, L2. And then we compared it, right? Toronto, Winnipeg, like this. And you notice, right, that Winnipeg has a bigger standard deviation, right? Meaning its temperatures are all over the place. And you know that, especially in April, right? It's all over the place. It could be mild. It could be super cold, right? So it would make sense that Winnipeg is a bit more spread out. And our ranges were also greater, right? The range is the difference between the lowest and the greatest was also, so there's a direct correlation between that as well. So we said that Winnipeg has a greater standard deviation, data is more spread out. The temperatures are vary greatly. That's what this is also saying, okay? To make a line plot, you're gonna have to be comfortable with line plots, right? So what do we do to make a line plot? I would say use your min and max, right? Which is given to us right here, right? There's the min and the max. Let that help you decide what should the scale be, right? What should be the lowest number? What should be the greatest number on that number line? And then pick a scale accordingly. Quite often when you compare, it's good to start with the same. So you pick the lowest point of both to make your starting point. and then you go up by the same scale, and we notice that Winnipeg was like, if you were to kind of make a curve above these points, it'd be flatter, right? Versus Toronto would be a steeper curve here. You should see that, right? You should see that difference. And we label mean, median, mode, right? You kind of want to label, tell yourself where is it on that graph, okay? So notice that the average for Winnipeg is right here, 0.5 degrees, whereas the average for Toronto was 6.83 degrees, right? So you kind of, maybe I'll just do it this way so you can tell, right? So you can tell that Toronto, on average, it's warmer, right? That's what the average, a higher average tells you that on average it's warmer. Winnipeg, on average, it's actually lower, right? Temperature, no surprise us there either. That's why I picked this, because we can kind of wrap our heads around it, okay? And so make sure you label, you put units down. I just did this to see, right, the range and the standard deviation again, right? You should see a direct correlation. I told you, right? At first it might be a little overwhelming, but page 3 kind of summarizes everything I'm saying here, right? That a lower standard deviation will give you a lower range, and data will be more consistent, and so the curve will be more like this. It'll be a steeper curve, and always the average in the middle. The min and the max are closer together. The range is closer, right? The difference between them is smaller, right? Whereas if you have a bigger standard deviation, this is on page 3, right? The range will be greater and it'll be more inconsistent. I can tell you only, like, let's say it's like, hey, if I told you data is inconsistent, what can you tell me about the standard deviation? You should be able to say, well, the standard deviation will be greater. You should also be able to say that the range is going to be greater. And you should also be able to tell me that data is going to be spread out. Look at the min and the max, right? There's more of a spread, right? And so that the curve, the resulting curve, we will do curves in a bit, right? Will be flatter, right? So it won't be as steep. So data is spread out. This is not consistent. And normally in this unit, we will kind of conclude that we don't want this. If you're buying a product on Amazon, I buy a lot of stuff on Amazon. I love Amazon. Don't have to go to stores all the time. But if the reviews are like this, have you seen the reviews where it's like, sucks, really good, right? It's all over the place. I'm like, wait a minute, this product is not consistently good, right? It has some issues. It seems like it's a hit and miss, right? We usually don't want that, right? If you read the reviews and most people give it like 4 stars, maybe they're like, yeah, it's pretty good. Maybe a few complaints here and there, but overall it's pretty good. Like most of the stars that are given are closer to that 4, then you're doing pretty good. I'm thinking, when you go down on the reviews and you see how many people got 5, gave it 5, 4, 3, 2, 1, right? You have these bars there. I will use that actually. Now I'm thinking about it. I'll use that to make the point, but not today. To make the point a bit clearer, okay? So anyways, you should be able to see that everything is connected, right? The graphs, everything is connected. The standard deviation and the range, everything is connected. And then this, we kind of ran out of time here, and I kind of it was a Monday for me, right? So I was a little rusty there, but yeah, describe the data sets for each city using the mean, range, and standard deviation, right? So I kind of focused on Toronto. So if you didn't write this down, it's important that you do. I'm just going to make it focus a bit more. So on page 5, so Toronto has a greater mean. So if we just talk about the mean first and foremost, it indicates that it is warmer than Winnipeg on average, right? So the mean, that's what it tells us. Is it could be a longevity of, like we'll talk about batteries. It could be a height, right? Like people are taller in one city or country compared to the other. So The mean, just look at the data and just base your answer on that data that you've collected, okay? Uh, the range and the standard deviation, I kind of combine them, right, are smaller, which means that most temperatures are closer to the mean compared to Winnipeg. And to summarize, data is more consistent, right? And you're like, what about Winnipeg, Mr. Davidson? Well, I kind of have compared it to Winnipeg, right? If I would have started with Winnipeg here, I would have said it has a smaller mean, which means that it's colder on average, right? The range and standard deviation are greater, which means that the temperatures are spread apart, right? They're more widespread compared to Toronto, and data is more inconsistent. Like you would say the exact opposite than what I just did here, and I kind of ran out of room, so I don't want to add more to it. But we'll have another chance on the next page. Maybe what I will do, I'll just give you a little. Maybe don't write it down right away. Let me first figure this out here. But if you were talking about Winnipeg, right? Smaller mean, right? Which means colder than Toronto, right? Right? Greater standard deviation and range, right? Temperatures vary more than Toronto, okay? And data is inconsistent. I think I made it work, so now you can feel free to write that down. Let me zoom into that. There it is. Sometimes forget, right? Like I've done this many times, so I think for you, you maybe need the other approach from Winnipeg side, right? What does it mean? If you're talking about the mean, which is average, right? What does it mean to have a smaller mean? It means that it's colder, right, than Toronto. In general, right? Greater standard deviation and range means that temperatures vary more than Toronto. And you will see me kind of saying the same thing in other examples, but I will use different terminology, and you should be comfortable with that. The fact that I'm kind of using slightly different wording, and feel free to use your own words as well, as long as it jives. It should jive with page 3. Remember, page 3 is like your go-to if you want to have a quick overview of what we're doing here. And so everything that we're doing here is trying to interpret data, right? What is it trying to tell us? So that's what we're trying to do here. We don't want to just have a bunch of numbers. We want to kind of interpret it and see what does it tell us, right? You remember during COVID, not that COVID is over, but you remember flattening the curve? Right? That was the thing, we're trying to flatten the curve, right? They were actually trying to make the cases spread out. They didn't want everybody to get sick at the same time, right? Because then the hospitals would overflow and stuff like that. That's exactly, it's coming from this unit right here. They wanted this to happen, right? With all the restrictions and stuff, they wanted a few cases here. And yes, there will always be a peak. There will be a peak, but they wanted this. Hospitals did not want this, right? Everybody's getting together at the same time, which means the incubation period, all of that is going to be the same, which means everybody's going to kind of get sick around the same time, right? The system cannot support that. So they actually wanted a greater standard deviation. The bigger the standard deviation in terms of cases, the better, right? Per day, cases per day, that is. and you will actually get ACs, where I use quite a bit of COVID. Actually helps for this unit. I'm not happy that COVID came along, but it actually makes this unit come to life, kind of thing. So let's keep going. I'm going to ask you to do some work here. Let's go to page 6. We're going to compare two different brands of batteries. Bless you. And just to make clear, there's the data is split right there, right? So brand X is here, brand Y is here. What in the world are these numbers representing, right? The lifespan. It's the lifespan of 30 car batteries. Okay? So all of these numbers obviously are in years. It tells you that. Okay. So what I want you to do is I want you to type these 30 brand lifespans into L1. Then I want you to find the mean, the median, the standard deviation, range, and mode of this data set. Okay, you remember how to do that? If not, you can use your notes. If you're really stuck, ask your neighbor. And if you're really, really stuck, you ask me, right? So you're going to do that for brand X. And then I want you to do the same thing for this one. But please don't erase L1, like especially when you're comparing data, you will put this into L2. I could have a third brand in the mix if I wanted to. We'll do that a little later. But right now we're just going to compare two brands. And then you do the same thing for brand Y. You find the mean, median, mode, and everything for that. And then we're going to create a line plot. We're going to describe, we're going to talk about those numbers. But I want you to think about, when you get these numbers, think about what do these numbers tell me? And then I'll take it back in a few minutes when I... All right. So let's see here. You type this one in, right? Just for notes, right? One variable stats, L1, right? We used for the first one. And we get 5.74 years on average. The median is 5.75. The standard deviation is 1.22 years. The range is given by, right, taking the greatest value, subtracting the smallest value from it. It's 5.1 years. And the mode, I will make a note here that I go sort A, right, L1 for this particular one. And you get 5.7 years is the mode. And it shows up 3 times, right? Shows up 3 times. That's why that is. And I will just add that N should have been 30, right? If you type in all the values and you calculate this and N is not 30, that means you missed one, right? So you got to watch out for that. It's a good check. Did you get the same numbers as me? Could I use your calculator for a second? I didn't type the same. Okay. So I just want to make sure this is already sorted, right? But to get the mode, right, you would just kind of just go through your numbers, and 5.7 shows up 3 times if you sort it, right? So you got to go stat, sort, right? Sort the first one, right? Press, once you see done, you can go back to it and it'll be sorted, right? So I just want to make sure, I don't know if you missed this yesterday, but that's how I get that. And to get the range, obviously you could just go by the numbers here, right? 3.1 is the smallest, and you go up, and then 8.2 is the smallest. You can do it that way as well. But I normally we'll just get it off of these results, right? And so the min is 3.1, the max is 8.2 right there. The median is 5.75, right? The mean is 5.74, which is that first number with the X bar. And the standard deviation is right here. Don't mix these up. A lot of students mix. So you got to be very careful. It's this one, right, with this lowercase sigma. So 1.22 is the number here. Okay. So hopefully you got that all right. And then so the second, I will do that exact same thing. One var stats. And in this case, I use L2. And I'll just give you the numbers that I have in my notes here. 5.72 years, 5.75 years is the median. And that's the same. And even the average seems to be about the same. They're very close, right? The standard deviation is 0.64. Let me just run that real quick. So I'm going to go to my main screen, borrow that one, and just change that to L2, right? And there it is, 5.72. I will 5.75 is the median, and remember it's in years, right? And then the standard deviation is right there, 0.64 years. And then the range, oh, I could have just stayed there, right? My bad. The range, I would just say min and max, right? So it'd be 7 minus 5.7, no, sorry, 4.5, right? And I get 2.5 years as my range. And it should make sense, right? Smaller standard deviation, smaller range compared to the previous example, right? You should expect that, right? And then my mode, is there a mode? Yeah, there is one. It's 5.9. 5.9 years is the mode. And I'm just gonna check here, right? 4.9, there's 2 of them. You keep going, 5.4, there's 2 of them. So far 2 modes, so far, right? But then you get to 5.9, right? 5.8 technically, and 5.7, 5.6, they all show up twice. So you have a bunch of modes until you get to 5.9, right? There's 3 of them, so that one wins overall. And so that is your, and again, just to clarify, I won't be going through this much detail normally, but n is equal to 30, right? Just a little check to see if you did everything right. Okay? Now, our number line, our line plot. So for the line plot, I will actually go to these values and pick the smallest value of them all. So you see that 3.1 is the smallest, right? So I'm thinking to start, and then the greatest value is 8.2, right? So if I go between 3 and 9, I'm pretty good. I'm doing pretty good. 3 and 9, I'll fit everything in. But you also want to be aware of, look at the numbers. You're going up by small increments, right? It's 0.1, 0.5, right? Like you have a bunch of decimals, so you need to be aware of that as well. So what I will do here, I'm going to grab my ruler, and I'm just going to draw a line here. This is going to be for brand X. You start at 0. Quite often I will give you a number line, okay? As at least a line to get you started. So let's see here. I'm going to use my ruler to help me out to spread it, place them equally apart, right? And again, will there be a right way to do this? No, right? You could choose completely different values and be fine. In fact, in my number line, I start with 1, even though I don't really need that. Okay, so how about we just start with 2? So this is 2, 3, 4, 5, 6, 7, 8, 9, and I'm already well above what I need, but that's okay. Could I have gone maybe 2 and then 3, 4, 5, 6, 7? I could have maybe done that as well, but I didn't. Okay. And because we're comparing, watch what I'm going to do. I'm just going to kind of make it line up. It's okay if you're off by a little bit, but so arrowheads on both sides, right? And then I'm just going to try to line it up. Watch, right? Like just go down here, and that's where I start. And then I use my ruler to help me with the rest. And I'm actually going to ask you to fill this in. All by myself? All by yourself. Okay, so I go to 13, even though it's overkill. A number line, you decide what you want to do with it, as long as you're able to fit your points on it. And you have to be a bit creative here. We're not going to split hair over, oh, did you put it exactly in the place? But what you do need to remember is to not have a smaller value ahead of the bigger value, right? Like that's something that I do pick on. So I will call this brand X, brand Y, and then just put what units are we using for it. So it's almost like an X axis without the Y. That's what a number line plot is. Right, so you determine the scale. What did I use? I kind of went by the greatest and the smallest values. I label with units, and now I'm going to plot it. You're going to need your calculators for that. Okay, the best thing is to use your sorted list, right? You use your sorted list and just start putting dots where they go, where they're supposed to go. So you go ahead and do that. And what if you have more than one? You stack them, right? You stack them. And it's going to be somewhat challenging. I'm doing it quietly, okay? So if you are wondering what's happening. If you're off by a little bit, that's not a big deal, okay? I kind of just want to see how this thing is spread out. Kind of just want to see what the spread is. So if you're off by 0.1, not a big deal. But I should see the doubles or triples. I should see them stacked. Right? So could you have picked a better scale? Probably. You could have spread it out a little bit more. But that's beside the point. You should see, as expected, brand Y should have been closer together, correct? Because it gave us a smaller standard deviation, so they're more clustered, whereas brand X is further spread out. Right? You should see that. So I will label the mean, all the average and all of that. So 5.74 is right about there. Be right there. So this is definitely my mode, right? Which is 5.7. So the average, the mean is 5.74, and the median is right there. Okay, so we'll just kind of have them at the same place because there's no point in throwing in another arrow there, because we kind of see that they're kind of close. All of them are close together. The mode is 5.7 years, right? So you label those, and same with this one. You label your mean, median, and mode. The mode is right there, which is 5.9 years. The average is 5.72, right? And the median, we'll just put it right underneath as well, 5.75 years. So at a first glance, if you just look at the MCTs, they actually are both very similar, right? If you look at the MCTs, they are very similar. What are the MCTs? The mean, median, mode, right? Note, right? I'll make a note here. Note MCTs, mean, median, and mode, right, are all similar. So when you just look at the average, say, hey, they both kind of seem to have the same average lifespan. So what's the big deal? Let's just take either one. It doesn't matter. Median doesn't really matter that much either, right? But remember this, that the median, if I ever ask you, the median tells us the point where in this case, half of the batteries would last longer than it. That's what the median is, right? Half will last less, right? Same up here. So that's what the median is. It kind of splits it in half. Okay, so let's talk about this further. You know what? I'll give you the buzzwords here. Brand Y, this one is clustered around mean, right? This one is spread out, right? Spread out, right? Further from mean. Like there are more points that are further from that average on this one, right? You can tell compared to this one. Your average is here. Everything is kind of, it's closer. Could you be better than that? Absolutely. You can probably find a brand that is even more consistent, right? I was watching an episode where they're comparing dollar store batteries compared to just the regular brand batteries. You know, you get the Panasonic or whatever for cheaper. They're actually pretty good. They're actually very consistent. I was surprised. Right? They're actually sometimes more consistent than Duracell and all the big brands, right? So they were doing this. Okay, let's go and talk about this using our own words, right? So describe the data using the mean, the range, and the standard deviation. So let's talk one brand at a time here. Brand X, right? Um, Slightly greater mean, therefore slightly greater lifespan. But it's slightly it's almost negligible in terms of decision making. If the price was cheaper, I'd still go right with brand Y. This wouldn't necessarily sell me on it because it's not a significant difference in lifespan, right? So we talked about the mean here, right? What about the median? Oh, sorry, the range and standard deviation, right? So that's a bullet there. Greater range, right? Data lifespans vary more than brand Y. Okay. Greater standard deviation, or I'm just going to use that symbol, right? Lifespans are more inconsistent, comma, since a standard deviation is greater. You could have also said, you could have kind of combined them and said the same thing about both, right? But I try to separate them so they kind of each get a line, but there should be some overlap. So then I'm going to cut this off here and talk about brand Y. Slightly lower mean. Okay, therefore slightly lower lifespan. Let me see if I can zoom in a bit more. Slightly lower mean, therefore slightly lower lifespan. Um, Smaller range. Lifespans are closer to the mean smaller standard deviation. Lifespans are more consistent and closer to the mean on average. Which brand would you recommend? I would say, especially given the fact that they have about the same average lifespan, I would most definitely take brand Y because of the smaller standard deviation. I want consistency, right? I don't want to like have a battery last longer and then the other one lasts a lot less. I'd rather pay for consistency, right? So everything else set aside, not talking about the price, I would just based on this, brand Y is the winner. Okay. Uh, since brand Y has a smaller standard deviation, it indicates, are we in English class or what? That the lifespans are more consistent. Um, Closer to the mean. Let's throw an average because I always keep on using mean, but it actually is the same thing. Closer to the average, right? Um, brand Y is therefore more reliable. I choose brand Y. Every couple of years, PISA is the organization. They test grade 9s or 10s. Maybe you wrote the PISA test. Some of you were selected for it a couple of years ago in the library. I'm not sure. But they test for like math and science and English worldwide across the countries, right? And so if they see countries with a big standard deviation, right? It's like the education system is not consistent, right? There's like some kids that don't know anything, some kids that know a lot, right? And so you have that spread. So something is happening there. So they try to tell the government, you know, like you need to implement something to make sure the education is the same for everybody, the level, all of that, right? So standard deviation is everywhere. You're actually going to hear that more and more now that you know about it. You're going to hear that if you listen to the radio, you might be in a different course. You're like, oh yeah, I remember standard deviation, right? What other factors should you consider before making a purchase, right? You can talk warranty. You can talk about price, right? Price or cost, definitely. How far you have to drive to get it, right? Things like that, you can definitely throw that into the mix. But everything else put aside, we just base it on average, standard deviation. Basically, average and standard deviation is going to be the biggest. I just want you to see that the range is connected to the standard deviation. Okay, let me see here. The textbook has some questions here. I will move on a little bit, but I want to show you what this looks like, okay? Because we don't use our textbook a lot, so you're gonna have to dust it off a little bit. But in this unit, I do use it a little bit from time to time. So you will see that on page 211. Don't write in your textbooks. This is a beater, okay? This is a write-off textbook, obviously, because somebody already wrote in it. But you're gonna compare, kind of do the same thing that we did already, right? You're gonna compare two different cities and their temperatures. I don't think that they ask you to do a line plot, but I would recommend you making a line plot for these, okay, to compare that, so you know if I throw an AC at you, you know how to do it, right? You're gonna talk about, test scores of two different classes, right? What do you see there? And notice that they often, right, they want you to find the mean median mode, but I want you to also find the range and standard deviation. Because I'll tell you a little secret, they don't talk about standard deviation yet, but I always like to talk about it right away because that's really where we're going, okay? So maybe if I can add that here to your homework, okay? Also find standard deviation and range, right? That's first bullet, and then make line plots. Trust me, you'll be a lot faster if you practice at least one more before Monday. Okay, it's not a whole lot, guys. It's basically just type it in and see what you get there. And we'll do the rest on Monday where we start graphing. There's two more graphs. Technically, the line plot is considered a graph. Okay, so we're gonna do that as well. I'm trying to think if I'll just leave it like that. So what I will do, because you don't have your textbooks, I'll just keep it up there and you can start already. You can type it into your calculators. So I'll give you the rest of today's class to just do that. Okay, so here are the temperatures. Find all those MCTs, range and standard deviation. Make a line plot for both, and then kind of do the same thing we've been doing in our notes. Can you see that? I hope so.